this is 15.5, area between two curves. So what we did in 15.4 was figure A. We found the area between a single curve. When it says curves, it just means like graphs or equations or functions or whatever. Okay. So in 15.4, we found the area between one curve, one function, and the x-axis. Like we would find that area there, and there, and there. What we're going to do now, though, is find the area between two curves. So really, you don't really care where the x-axis is. Like between A and B, we're not comparing it up to the x-axis. We're doing between the two curves right there. And here between the two curves. And here between the two curves. Okay? And the way we do this, there's three little areas, and I'm actually going to color them different colors so you can see what I'm talking about. So focusing on that first little area right there, I'm going to integrate from A to B, okay, because you always go from smaller to larger. And then what you do is you do the top minus the bottom. So you go from smaller to larger, and then you do top minus bottom for your equations. How do you know which one's on top, which one's on bottom? Start at the top of your paper. If this is the top of my paper and I come straight down, and I'm coming straight down between A and B, which is the first equation I run into? This line here, which is g of x. So g of x is on top, minus, and then if I kept going, I would hit this one. F of x is on bottom. So that's how I'd find the little blue area there. Then I have this area going on. Okay? So it goes from B to C, and I want to do top minus bottom. So again, here's the top of my page. I'm going to come down straight between B and C. The first equation I run into is f of x. Minus, and then if I kept going down, I'd run into the bottom equation. Okay. Plus, and then if I had this little area over here, it's going to go from C to D, top minus bottom. So if I start at the top, first equation I hit would be G minus F. So when you're finding the equation between two curves, it's always going to be top curve minus the bottom curve. Top minus bottom. And let's look at a few examples. Find the area bounded by these two functions on the interval from -1 to 2. So we definitely need to see what these look like. Let's pull up our calculator. I'm going to go to y equals, and I'm making note to myself. I'm putting this one in y1, and I'm going to put this one in y2 so that I know what to do after all this. So in y1, I'm going to have 2x plus 3. And y2, I'm going to have negative x squared plus 1. And I'll just hit graph. Boom. So they don't even overlap or intersect or anything. So I'm going to draw them right here. That was awful. Let me try that line again. Much better. All right. And it says we're looking for the area bounded between these two curves on the interval from -1 to 2. So if you look, -1, notice I didn't even draw my x-axis. Whenever you're looking for the area between two curves, drawing the x-axis usually gets in your way. And so I usually don't even draw the x-axis. All right, but -1 is about right there. So what I'm going to do is come in and say, I'm going to pretend that's -1. And then to 2 is over here somewhere, right there. So I'm going to come in and say, that looks to be about 2 to me. And I'm finding this area between the two functions from -1 to 2. So that means I'm going to be integrating from -1 to 2, the top function minus the bottom function. Now, if you've already forgotten, obviously coming down, this blue one here is on top. You could say, oh, look, that's the line, so I know that's y1, but let's pretend we are really not thinking today. You could come over here and hit trace, and see which one it's bouncing on. At the top, it tells you which one it's on. So y1 is that one. So the top equation, if we came from the top of the paper down, our top equation is y1, and our bottom equation is y2 in this case. And I'm writing it like that because it'll be easier to type it in my calculator this way. So I'm going to hit second quit. I'm going to go to math, number 9, from -1 to 2. And right here, I'm going to type in y1 minus y2. Now, if you have a TI-83, the first thing you do is type in y1 minus y2. So I'm going to go to vars, y-vars, function y1 minus vars, y-vars, function y2. And this is with respect to x. And we get 12. So again, if you have a TI-83, when you go to math 9, it's going to say function integrate with a parentheses. So the first thing you'll do is you'll type in y1 minus y2, comma, and it's with respect to x, comma, from -1 to 2. And hit enter, and you will also get 12. All right. Example 3. Find the area bounded between these two functions on the interval from 1 to 5. So I am going to go to y equals, and I'm going to clear out what I have in there. I am going to come over here and make notes that I'm putting this one in y1 and this one in y2. So in y1 I have 3 divided by x, and this one 4 divided by x squared, and zoom 6. All right. And this is on the interval from 1 to 5. So we're just kind of looking over here. And if you don't have a colored graphing calculator, your lines are probably looking all kinds of jumbled right now. So I'm going to show you what to do, all of you. So since we only want to see basically quadrant 1, we're going to zoom a box around the part we want to see. So what we do is we go to zoom. Choice number 1 says box. Okay. You may or may not can see it, but your cursor is blinking right now at the origin. So what I want you to do is I want you to hit enter. And that's going to pin the cursor down right there at the origin. It just pinned the box down in that corner. Now I want you to move to the right, and I want you to move at least past 5, because that's what we're looking at on the interval from 1 to 5. And you can see at the bottom the numbers. So go at least past 5. And then I want you to move up to where you're at least can see that point of intersection happening there. Once you have your box drawn, if we hit enter again, that box is going to become our whole screen. So enter. If you missed that, stop the recording, rewind, listen again. So these are overlapping. From 1 to 5, they are having a little overlap happening here. So I'm going to draw my 2 lines. There's one of them. Here's the other one. Okay. And then I'm going to find that point of intersection real quick. So if you figure out how to find points of intersection, this is where we're going to go to second trace, choice number 5. Second trace, choice number 5. And it's going to say first curve, second curve, guess. So there's only 2 curves being graphed. So when it says first curve, hit enter. Second curve, hit enter. Guess, hit enter. And at the bottom it'll say intersection. And the only one we really care about is the x value, because when we integrate, our limits of integration are always the x values. I'm just going to do 3 decimal places there. All right, so I'm going to write that down in case you need that. So we went to second trace. Number 5 was intersection, and then we hit enter 3 times. Okay. So what we're trying to do is find the area bounded between these 2 curves from 1 to 5. So if that is intersecting at 1.333, then that means 1 is to the left of it over here. So I'm just going to draw like a little vertical line there and say that's about where 1 would be. and then over here, that's about where 5 would be. So I'm looking for that area in between there and that area in between there. And we're having to break it into these two parts because they switch places of which one is on top. Okay? So speaking of, hit trace and start moving your cursor so you can see where Y1 is. So this is Y1, this one's Y2, and so that means this one's Y2, this one's Y1. And I'm going to have two parts here. So for this first part, I'm going to be integrating from 1 to 1.333. The top equation minus the bottom. So start at the top of your page. Start at the top of your page and come straight down to that spot. The first equation you're going to hit is Y2 minus the bottom equation. And then you're going to add to that the integral from 1.333 to 5. So top equation here is Y1 minus the bottom one is Y2. So over here I'm going to go second quit, math, number 9, from 1 to 1.333. I'm going to go to vars, y-vars, function, y2, minus vars, y-vars, function, y1, and that's with respect to x, and that's the number I get, 0.137, plus, then I got to do the other one. I'm just going to hit second enter, and I'm going to come in and change, I got to change a lot of things actually. So I'm going to change this to 1.333, and I'm going to change this one to 5, and I'm going to hit delete, delete. I need to insert, I can just do minus vars, y-vars, function, y2. All right, so now I'm going from 1.333 to 5 of y1 minus y2, and I get 1.765, and I add those together. So these numbers should always come out positive because you're always doing the top minus the bottom. So you never need absolute value when there's two curves involved because you're doing top minus bottom. You only need absolute value if you're doing one curve and it's below the x-axis. All right, 3 more examples. Example 4 says, find the area bounded between these two curves. So what's different on this one is it doesn't give us an interval. It doesn't give us from x to x, so it must be completely bounded just between the two curves. So I'm going to go to my y equals, and y1 is x squared minus 5, and this one's going to be the natural log of x plus 2 minus 2. We messed with our graph earlier by doing the box, so I'm going to do zoom 6 to get it back to a normal graph. So I did zoom 6, and then we can see right there where it's bounded. So when you think bounded, think that there's like an area there where if you put cows in, they would not be able to get out. All right, so from here to here, this is our bounded area. Notice again, I don't draw my x-axes when there's two curves because they just get in the way. I do need to know what these 2 points of intersection are, or more importantly, I need to know what the x values of the intersection are. So I'm going to go to second trace, number 5. First curve enter, second curve enter, guess enter, and it gave me the one on the left over here, and I just need the x value. So negative 1.511. and then I'll find this one over here on the right. So I'm going to do second trace number 5. And instead of enter, 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 I'm going to do enter, enter, and I'm going to have to change my guess closer to what I want, and then enter. And I get 2.1. So I know that I'm integrating from negative 1.511 to 2.1. And I need to be doing the graph on top, so up here's the top. The first one I hit is that one. So if I need to hit trace and see what's going on, I can see y1 is that bottom graph. So this is y2. So it's y2 minus y1. All right, second quit. I'm going to go to math 9. I'll type in my limits. I'm going to go to vars, y-vars, function y2 minus vars, y-vars, function y1. And I get 9.12. All right, number 5. It says find the area bounded between these two curves. Again, no interval, so we're just going to see where it's completely bounded. So I'm going to y equals and clear out what I have in there. And I have 4x cubed plus 6. I don't like when I do that. Plus 6x squared minus 2 and 3x and graph. There they go. So it looks like there's 2 parts. Definitely not going to draw my x-intercept on this one because that would really make it congested in there. Notice how I'm also over-exaggerating my slant to this just to make it, I can see my areas better. So I've got this area and this area. So I need to know what these points of intersections are. I've got 3 of them. So I'm going to just do second trace, number 5, enter, 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 and it gave me the middle one first. I just care about the x value. So negative 0.416. All right. Then I'm going to go to second trace, number 5, enter, enter, and I need to change my guess, and then hit enter. Make sure it says intersection at the bottom. And I have negative 1.764. Then I'm going to go to second trace, number 5, enter, enter, and I'm going to change my guess, and enter, and I have 0.681. All right. So for that first part, I'm going to be integrating from negative 1.764 to negative 0.416. And for that part, my top one, going to be the blue one. And we can look right here where mine is, but let's just do trace. So you can kind of follow it and say, oh, look, that one is y1. So that's y1, that's y2. That means that's y2, that's y1. So this first one's going to be y1 minus y2. And then I'm going to integrate from negative 0.416 to 0.681, and for that one, it's going to be y2 minus y1. All right. So I'll show you something different this time. You could type these all in one line. So I'm going to go math, number 9. Negative, this only works when you have 2 curves. This doesn't work when you're doing the absolute value of 1 curve. So 0.764 and negative 0.416 This is going to be vars, y vars, function y1 minus vars, y vars, function y2 with respect to x. And instead of hitting enter, I'm just going to hit plus. Math 9, negative 0.416 to 0.681. And that's going to be vars, y vars, function y2 minus vars, y vars, function y1. And enter. And we get 4.563. All right. And on this one it says, find the area between these two graphs on the interval from 1 to 4. So I'm going to go to y equals and clear those out and graph negative 2 times x minus 3 squared plus 5 and then 2x minus 2. And I'm going to hit graph. And then it says on the interval from 1 to 4. So here's 1. So it does look like that point of intersection is important. Okay. I'm going to go ahead and just roughly draw my two graphs. All right. So I'm going to find my first point of intersection. I'm going to go to second trace, number 5. Enter, 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 and I get that first one is 1.634. And I'm going to find the second one. Second trace, number 5, enter, enter, enter. I just found the same one again. Second trace, number 5, enter, enter, change my guess. And I got 3.366. All right, and it's wanting me to find the area between the curves from 1 to 4. So 1 would be to the left of this, so I'm just going to draw a vertical line here and say, let's pretend that's 1. So I'm looking for that area, and I'm going to be looking for all that area, all the way to 4, which is on this side somewhere. So I'll just draw 4 there. So I've got 3 little areas I'm finding. One of them is going to be from 1 to 1.634. One's going to be from 1.634 to 3.366. And one of them is going to be from 3.366 to 4. So I'm going to hit trace and start moving. So I can see that that one right there, the curved one, is in y1. So this is y1, which means that's y2, this y1, y1, y2. So coming from the top down on the area you're looking for that first one, it's y2 minus y1. For this next one, it's y1 minus y2. And for the last one, it's y2 minus y1. All right. I've done a million of these for you, so pause the video and see if you can come up with the answer yourself. And you should get 3.464. Yay.